Warm greetings everyone. Thank you for being with us today. This is Muntasir, Country Director of IFDC Bangladesh. Today with us we have Dr. Upendra Singh present. He is the Vice President of Research at IFDC. He has long shining career in agricultural research around soil health, efficient use of fertilizer, smart irrigation, high yield crop varieties, mechanization, greenhouse gas emission, and different farming practices.
Thank you, Muntasir. Yes, I have been with IFDC for about 35 years. I'm originally from Fiji Islands. I've been coming to Bangladesh, mostly agriculture-related trips, since 1986. I'm also very proud of all the activities that have been conducted by IFDC during that period here.
IFDC has been working in Bangladesh since 1978, collaborating closely with government, private sector and many other players, especially with farmers. Would you reflect some of the key contributions of IFDC in Bangladesh?
Yeah, it's a very interesting role that IFDC played. One of the major highlights for me of IFDC activities in Bangladesh was related to agribusiness. And this was done in the 1980s when IFDC implemented the ATDT project with USAID. And the major focus of that project was actually, as I said, agribusiness. And surprisingly, IFDC, which is mostly associated with fertilizers, was the main initiator of bringing hybrid maize to Bangladesh. And why was that done? That was mostly to increase the yield of maize. And main purpose for that was again associated not with human consumption, but the requirement for poultry industry. So if you want to grow your poultry industry, you need to have feed, and so that was one of the investments or initiations that IFDC had taken in terms of the agribusiness side of which is away from the research part that I'm normally involved in. With urea replacement, and popularly known in Bangladesh as urea guti, but the country that really continued to use, at least the farmers and the researchers that continue to promote UDP or urea replacement happen here in Bangladesh. So IFDC continued to work with the research institutions, with farmers, and most of the developments associated with UDP, like the making of briquettes. So you need a briquette machine. So many local entrepreneurs, industrialists, got involved and developed and even fine-tuned the version that was originally brought from IFDC. You'll be surprised that if you go back to IFDC, you will see a briquette machine that has been manufactured in Bangladesh, and IFDC imported that because it's much better, more improved than our original version. So there's been a lot of, so that's one side of urea replacement where the private sector got involved. The other part of it was, once you have that machine, having entrepreneurs to buy into it, because urea briquettes are not something that you make in a large factory. Fertilizers are not handled with the tender loving care. They are dropped from trucks. And so if you have a guti or a briquette, when you drop it, it will break. So that's why the manufacturing of those urea briquettes or gutis need to take place at the village level. So that's where the village entrepreneurship came in, where local agribusiness dealers were willing to invest and buy that machine. Initially there was some subsidy given by IFDC, but eventually it was totally removed, and people were willing to buy those machines on their own. What's the other interesting part about urea displacement is that IFDC promoted it for rice. Bangladeshi farmers started using it in other crops. They saw it worked so well in rice. They said, why can't we try in our vegetables, fruits and brinjals and tomatoes? And so they were the ones who really started it. And then institutions like Bari, they said, okay, let's do some research on it. So it was, interestingly, farmers who started using urea briquettes for non-rice, for upland crops and vegetables and so on. So by displacement, you are also doing that at the same time. So what are the benefits that are coming out of that? First, you are having less labor, less energy use for tractor application and all that, so one time only. The second one is that you are also using less fertilizer, so that also means there would be less energy use in terms of producing the fertilizer. You are only using 60% of the fertilizer rather than all of it. So that's also, again, another positive thing in terms of your carbon footprint. The less fertilizer you produce, there is less emission. And third one itself is when you apply the fertilizer, it's not just all running, going into the air or getting run off into the flood water, with water level going up and down. So you don't lose it from runoff or leaching. So all of this really makes that displacement a very interesting technology and interesting topic. Technology, of course, has to play a very critical role. So anything that we can do to improve efficiency, I keep repeating that word efficiency because the opposite of efficiency is waste, and we cannot afford to waste. Some of the resources that we use are very critical. Water is one of them. People are paying attention to soil health. That's very important too, because what we grow on the soil has an implication on the health of everyone. The plant health, animal health, and human health. All of these are connected, and this also is linked to soil health. So the importance of soil health, water quality, all of these things really means that we have to use technologies to help improve the way we use our resources, so that we minimize on wastages, we improve on recycling, and so what are the technologies that are available that can help us recycle our waste properly? We need the fertilizers, but can we replace 20% of the fertilizers by recycling? And so that's another area where technology can play a very critical role. Bangladesh is an exception because it's a very agricultural country, so there are the population density in the villages are not that low, but they are still. But when you look at the concentration, it's majority in Dhaka and in large cities. That also means that when we are harvesting our produce, whether it's rice, wheat, vegetables, it's moving from those villages to the cities. Together with our food, we have nutrients that are moving. And so, of course, some of those nutrients are used because it's consumed by humans or livestock, however it's being used. But once there are waste, they are concentrated in the cities. How do we take care of that waste? How do we bring the nutrients back from the cities to the villages? Because villages are where basically how do we take it to the farms, because the nutrients are needed in the farms, they are not needed in the cities. They are a headache in the cities because they cause pollution. You see your lakes and rivers are looking thick and green. We don't need algae and aquatic things growing in the river. We want it to be growing on our farmland. We need those nutrients on the farms and not in the rivers. So technologies are needed that can speed up that process of taking the nutrients back to the farms. And it's not going to happen by taking truckloads of waste, because that's an expensive proposition. How do we convert that loads of waste into nutrients, into something that farmers can use, incorporate it with their urea or whatever other fertilizer they are applying, DAP or MAP, and use the recycled products as well. So that's where new technologies are needed, and that also helps the government. If you can import 30% less fertilizers, that means you are saving so many million takas by saving that and using your recycle waste. There's always a constraint in terms of making that research more adaptable, taking the research from research to practice, and that's where many institutions fail, because the research is very high caliber, but the adaptation or the extension component is not there. And that is something that IFDC has been very aware of. So we do, when we look at our strategy, when we are looking at technologies, we make sure that there is a component that involves many stakeholders. This is a critical part of a research institution, and in that way IFDC is very unique, because if you look at on the production, commercialization, on fertilizer production and accessibility, mostly on the production side, IFDC has a pilot plant. And so this allows things that are the technologies and fertilizer products that are coming out of labs and academia, can that be commercialized? And the way to find that out is to scale it up, to try it at a small pilot plant scale level, because you will not find a multi-million, or even a smaller company willing to take a risk of producing something in their plant that produces 1,000 tons per hour. That means they would be taking a lot of risk if your product fails. So the commercialization part, scaling is critical. So our pilot plant saves that gap. The other side of the story is technologies that are going to go out to the farmers. This is where we have our own team that is involved in demonstrations, scaling to some extent, or we work with our partners. In Bangladesh is the Department of Extension. In other countries it may be private sector partners. Even here in Bangladesh we've also used private sector partners to evaluate and scale technologies. So that's one way the research gets into action, by having partners, food production, food security, is critical, and you know, it affects everybody.
Thank you. Thank you, everyone.